Hello everyone, today we are going to learn about longest increasing subsequence. But at first, let's learn what is subsequence. Subsequence is a sequence which is made up within the sequence. It gives information about the sequence. It can be continuous or non-continuous. For example, a sequence is 10, 11, 12, 13, 14, 15 which is continuous, and this subsequence is 11, 12, 13. So there can be other subsequences also, like if we can also take 13, 14, 15. So this is subsequence. Now what is a sequence? Sequence is an order of events we follow to complete the task. It simply is an order of events which is series of steps we follow to complete the task. We use it to complete the task in a correct way. For example, a sequence can be 1, 2, 3, 4, 5 which can be continued to 20, or 13, 11, 13, 15 which can be continued to 99. So this is the sequence. Then what is the longest increasing subsequence? Before learning longest increasing subsequence, let's learn what is increasing subsequence. The next number of the sequence will always be greater than the previous number. Here, as an example, we can see 2, 3, 4, 6, 9, 10. Here we can see that 10 is greater than 9, 9 is greater than 6, 4 is greater than 3, 3 is greater than 2. So it is increasing in number. So this is called increasing subsequence. The longest increasing subsequence problem is to find subsequence of a given sequence in which the subsequences element are in sorted order, which is lowest to highest, and in which the subsequence is as long as possible. Here there is a given example of a sequence, and the length of the alias, which is longest increasing subsequence, is 6, and the alias is 0, 2, 6, 9, 11, 15. Now how did we find it? So in order to find the alias, we have to use dynamic programming. Now what is dynamic programming? Dynamic programming approach is similar to divide and conquer in breaking down the problem into smaller and yet smaller possible subproblems. But unlike divide and conquer, these subproblems are not solved independently. Rather, results of the subproblems are remembered and used for similar or overlapping subproblems. Dynamic programming is used where we have problems which can be divided into similar subproblems so that their results can be reused. Before solving the enhanced subproblems, dynamic algorithm will try to examine the results of the previously solved subproblems. The solutions of subproblems are combined in order to achieve the best solution. For example, if we write simple recursive solution for Fibonacci numbers, we get exponential time complexity, and if we optimize it by storing solutions of subproblems, time complexity reduces to linear. Now, solving a alias problem using a naive approach. Let Li be the length of a longest increasing subsequence ending at position I. Now what does this line mean? So for length I, what is the longest increasing subsequence? The I can be either 4, 6 or any number. So if, for example, let's take I is equals to 5. So you have to find the longest increasing subsequence for L5. So this is the formula given. Let's find the longest increasing subsequence of the given sequence below, which is 9, 5, 3, 7, 11, 8, 10, 13 and 16. In the table we can see that their index and input are given 0, length 0, because as 9 is the first element of alias, there is no other input to compare it with. So we'll just take 9 and the length of 9 will be 1. Then index 2. Now index 2 cannot be compared with 9 because we are solving longest increasing subsequence problem. So it is not increasing. So it will not be compared with 9 but 0. So the length of 0 is 0 and length of 2 is 1. So 0 plus 1 is 1. The length of 2 is 1. Then 5. 5 will be compared with 2 because 5 is greater than 2. So 1 plus 1 and the length will be 2. Then for 3 it will be compared with 2 and the length will also be 2 because 1 plus 1 is 2. Then for 7 can be compared with either 2, 3 or 5. So if we compare 7 with 2, then up to 2 the length is 1. So 1 plus 1 is 2. Then if you compare it with 3, the larger length is with 5. we compare it with 3, 2 plus 1 is 3, and if we compare it with 5, the length is also 2 plus 1, which is 3. Therefore, a larger length is with 5 and 3, so we will take the larger one. Either we can take either 5 or 3. So the length of 7 will be 4. It's 3. 1 plus 2 is 3. Then for 11 can be compared with all the inputs before 11. So we will take, as our goal is to maximize, so we will compare it with 7, the largest input between them. So the length will become 3 plus 1, which is 4. Then for 8, we will take the larger input again for the same reasons. So the length will become 3 plus 1, which is also 4. For 10, the maximized option will be 8. For 13, it will be 10, and for 6, it will be 5. So the length will become 5, 6, and 3 respectively. So now our next step is to find the largest length of all of them. So we can see 1, 1, 2, 2, 3, 4, 4, 5, 6, 3. So largest length is 6. So we'll take the input for 6, which is 13. So then after taking 13, we'll see the previous of 13, which is 8. So the 8, so the index 8, for index 8 the length is, input is 10. We'll take 10 and then see the previous of 10, which is 7, and then the index 7 has input of 8. We'll take 8 and then we'll see the previous of 8, which is 5. Then the 5's index 5 has input 7. Then we'll take 7. After taking 7, we'll see the previous of 7, which is 4. Index 4 has input 3. We'll take 3. Then we'll see the previous of input 3, which is 2, and then the index 2 has input 2, so we'll take 2. And then finally we'll see the previous of 2, which is 0. Finally, it is 0 is the starting number, so we'll not take it. So this is the final LIS, largest increasing subsequence, which is 2, 3, 7, 8, 10. So this is how we find longest increasing subsequence using dynamic programming. Thank you.